this video, we will be demonstrating the pin-jointed frameworks experiment, the STS8, within the next generation structures range of engineering teaching equipment from TecQuipment. This pin-jointed frameworks experiment allows the study of strain, stresses, forces and deflections in various pin-jointed frameworks included, and the study of Bow's notation. Many structures use frameworks or trusses such as the roof truss or Warren truss in civil engineering, or space frames in vehicles and aerospace engineering. With this experiment, you can look at 4 popular frameworks to learn about the forces on each member and the overall framework deflections. Engineers need to know how the external forces on the framework affect the forces on individual members and the overall framework deflections, so they can be sure that each element of their structural design will stand the forces without fail and not deflect excessively. Let's take a closer look at the pin-jointed frameworks experiment. As with all the experiments within the next generation structures range, they mount on the structures platform that is available separately. The 4 frameworks in this experiment are a simple cantilever truss that we can see here, and an advanced cantilever truss, the Warren truss and the roof truss. Students use a load cell to measure and add loads to the framework under investigation. These frameworks are held on supports. Strain gauges on each member of the framework measure the forces due to the load, and a precision digital indicator measures the deflection of each framework. First, we're going to take a look at the cantilever trusses in more detail. This is where you start to learn about this topic, allowing the students to become familiar with the equipment and explore the relationship between the applied load and the forces in the members. Students can also learn about pin joint theory and the ability to predict member forces. With the experiment set up like this, you then connect the cable from each strain gauge to its respectively numbered socket on the strain gauge interface amplifier. This is then connected to the USB interface hub. This is then connected to a computer running the free-to-download VDAS software, and you use that to collect, chart and help you analyze the results. You also have the option to upgrade VDAS to unlock the VDAS eLab functionality to allow students to engage in the experiment remotely on their own computers for individual data capture and analysis anywhere in the lab, building or the world. Another feature of VDAS software is that you can carry out simulations of experiments. Back to the experiment now. By applying loads of 100 newtons incrementally, record the number forces in the table to a maximum of 400 newtons. You can then chart member force against applied load and examine if the force in each member increases linearly with the load or not. The second truss is the advanced cantilever truss, following the same experiment process this time with the advanced cantilever shown here. The user guide prompts students to consider the role of members that carry zero or very little load. For further study on this, you can also angle the load, simulating a load on the structure that has swung inwards like a crane with a wrecking ball. The Warren truss, as you can see here, looks at the relationship between the applied load and the forces in the member for the Warren girder. The last experiment is the roof truss, where you can illustrate and confirm the principle of superposition. You can do this with both a vertical load and a horizontal load, as well as combining these loads. It's worth noting that to do this experiment, you do need an extra load cell not available as standard with the experiment kit. For more information on the pin-jointed framework experiment, click on the links below. Another experiment within the next generation structures range that might be worth checking out is the bending moments in a portal frame experiment. That's the STS8. We regularly create new video content, whether it's demonstrating an apparatus, carrying out an experiment, or sharing videos created by students from around the world. So why not subscribe to this channel? Thanks for watching.